Hello again everyone, this is Vincent, and I'm sorry for the delay in the videos, but real life and writer's blanks do get in the way of making videos. I'm just leaving the Steambirds for now because the other ones haven't been so popular. I'll just let them sit for maybe a week or so to get more views. Yeah, the writer's blank was because I was just thinking of ideas of what to do that would not, apart from the ones I've always said, which would be slightly more entertaining. I don't think I've got another entertaining one, but maybe the American, it might be entertaining because my idea is that I'm going to be revising school subjects by explaining them as a commentary, but at the same time I do them in a different accent, like American accent or something. Yeah, so here goes. I'm just going to be doing some maths. So I'm going to explain the modulus function, which is notated by two vertical bars. And what the modulus function means that whatever's inside the two vertical bars, when put into the equation, you always take the magnitude or the positive value of it when you're considering linear equations. So, for example, if you had the magnitude of -7 which would be inside the two vertical bars, then the magnitude is equal to 7 because whenever you have the expression inside is negative, you multiply it by the whole expression by -1 in order to make it positive, and it stays positive if it is positive. So if you were to have the absolute value of x, whenever x is positive, you replace it with x because x is positive. But when x is negative, whatever's inside is negative, so x is negative, you multiply by -1. So when x is less than 0, which means it's negative, you take negative x to replace the absolute value because that would make it positive, but with the same magnitude or modulus. In different contexts, like complex numbers or vectors, the modulus function has a slightly different meaning, but in linear equations, the meaning is taking the magnitude or positive when it's positive or negative when it's the multiplied by -1 version when it's negative. When you have a linear equation. So, for example, if you had the modulus of x is equal to 5, you have to consider two different cases when whatever's inside the bracket is positive and whenever whatever's inside is negative. So for example, modulus of x equal to 5, you have to consider when x is positive, when x is negative. Which happens at x is equal to 0. When x is greater than 0, then it's positive, and you replace the expression with x. And when x is less than 0, you replace the expression with negative x, so it has the same magnitude, but positive signage. So the absolute value of x, when x is greater than 0, you take x is equal to 5. That's your answer. But when x is less than 0, you take negative x is equal to 5. So x is equal to -5 to solve the equation. You can also have a linear equation inside the modulus function. So, for example, the absolute value of x minus 7, all in the vertical bars, is equal to x minus 7 is equal to x minus 3 is equal to 5. So again, you'd have to consider two cases when x minus 3 is positive, when x minus 3 is negative. So when x minus 3 is positive, when x is greater than 3, you'd have to solve the equation x minus 3 is equal to 5, which is equal to, and x is equal to 8. And you have to consider 3 minus x is equal to 5, and when you have to consider x minus 3 is less than 0, you'd have to replace the expression with 3 minus x, which only happens at x is less than or equal to 3. And solving 3 minus x is equal to 5, you get x is equal to negative 2. You can also have absolute values on both sides. So, for example, the absolute value of x is equal to the absolute value of x minus 3. Here, you'd have to consider 3 cases because there are two different regions. Because the absolute value of x has its 0 point, or the point where it changes from positive to negative at x is equal to 0, and x minus 3 has its 0 point at x is equal to 3 when x minus 3 becomes 3 minus x. So you have to consider x is less than 0, x is greater than 3, and x lies between 0 and 3. So x is greater than 3, then both are positive. X is equal to x minus 3. Then, but that would be a contradiction, because you'd have 0 is equal to negative 3 by subtracting x from both sides. So the answer doesn't exist for x is greater than 3. For x lies between 3 and 0, you have to x is positive, but x minus 3 is negative. So you'd have to make x is equal to 3 minus x. And solving that, 2x is equal to 3, and x is equal to 3 on 2. Then you have to consider the case when x is less than 0. So both expressions are less than. We'll have to take the negative version. So 3 minus x is equal to negative x. And again, by adding x to both sides, you get a contradiction. So the answer doesn't exist at that point. In other cases, you also need to take into account that the domain. You have to also take into account the domain, or the x values which you're considering. So if you were to get the solution where x is equal to 5, but the function only exists for x is equal to is less than 3, then that would not be a solution. I can't keep this up. I have less than a minute. Okay, well, I think I'm gonna finish my commentary there. I hope I didn't offend anyone with my probably bad American accent, but, this is the end of the video, and I'll see you in the next one.